Alright, welcome back to the video tutorial about factoring polynomials. We got cut off by the 10-minute mark last time. Sorry I did not warn you. So we factored the difference of two squares for a second example. 131x squared minus 144y squared gave us, in parentheses, 11x squared minus 12y multiplied by 11x minus 12y multiplied by 11x plus 12y. And that is the pattern that you'll have to memorize for this difference of two perfect squares. Alright, so let's move on to the next form, which is the difference of two perfect cubes. Now, if you're starting off with factoring polynomials, you might try to approach this as we did with the difference of two perfect squares. However, you have to beware because this is not the same. If you remember from the expanding polynomials video, in this case we applied the pattern ax minus by a squared x squared plus abxy plus b squared y squared. Sorry about that. So when we were expanding polynomials, we expanded this polynomial in order to find the difference of two perfect cubes. And now we are going to apply that in the opposite direction by trying to factor x cubed minus 8y cubed. So in this case, the a value would be 1 since, the a value would be 1 since we only have x cubed, and the y value would be the cubic root of 8, and that would give us 2. So let's just plug it into this formula here. We would have x minus 2y multiplied by, in parentheses, x squared plus 2xy plus 4y squared. Notice that this is very, very different from the difference of two perfect squares. Do not make the mistake of confusing these two because they are extremely different. This is also another rule that you will have to memorize in order to factor these sorts of polynomials extremely quickly. Also, a second mistake that you might make while you're beginning, when you're a beginner in factoring, do not try to factor this polynomial, this quadratic polynomial here, x squared plus 2xy plus 4y squared. This is indeed irreducible. This might mirror the form x squared plus 4xy plus 4y squared, plus 4xy plus 4y squared, but unlike that, this cannot be factored. I'm putting across an x through it to say that it cannot be factored. It is indeed irreducible. So you would leave it at that. If you do not believe that it is irreducible, try to factor this. If you find the master product, it is 4, and when you find all the factors of 4, you can find that none of them add up to 2. So it is indeed irreducible. Alright, so let's try another one of the same form. And this one is, that should say, that shouldn't be 16. Let's make that 64. Seems like a pretty round number. Alright, so once again we are applying this formula over here. In this case, the a value, the a cubed value is 27, so the a value would be the cube root of that. That gives us 3, and the b value would give us 4. It would help a lot to write out the b value so that you don't get confused with the powers. So when we plug this in, this will look like 3x minus 4y multiplied by, in parentheses, 9x squared. We now have a non-1 a value, plus, so it was abxy, that would be 12xy plus 16y squared. Now once again, I have to reiterate, do not try to factor this quadratic polynomial. Take it from a person who tried for, who, when I initially learned this, tried for the life of me to factor that. It is not very possible. The master product simply does not have factors that adds up to the middle term. So this will be the final form. Alright, so now let's try to factor the sum of two perfect cubes. Now, this just emphasizes the difference between the difference and sum of two perfect cubes and the difference of two perfect squares. There is no sum of two perfect squares. That would just yield that would give you numbers that are imaginary. However, with the sum of two perfect cubes, that is indeed possible. And if you remember from the expanding polynomials video, this the formula for the sum of two perfect cubes is ax plus by multiplied by a squared x squared minus abxy plus b squared y squared. Alright, so in this case, the a value is 1 to make things simple, and we can just once again plug it in to find x plus 5y multiplied by x squared minus 5xy plus 25x. Once again, this quadratic is irreducible. If you really think about it, this form is the exact same as this formula. If you plug in negative b values, if you consider the difference between these two forms, it is that the b value, b cubed, or the b value itself, is either negative or positive. And if you plug in, say, a negative b value into this, that will give you this one. So they are in fact one and the same. However, it helps to memorize both, so that just as a shortcut. Alright, so let's try this now with negative 64x cubed plus 1331 y cubed. So there are two ways to do this. You can either right off the bat try to factor out a negative 1 to remove the negative, and that will simply give you the difference of two perfect cubes.